absolutely delighted to have with me today Rob Gess. Rob is a research scientist at the Albany Museum and is also a research fellow of the Paleosciences Center of Excellence. Rob has this incredible experience of working in the Devonian rocks, and he is one of those persons who has an untapped resource of all these wonderful fossils that have come out of the site. So Rob, please, can you tell us some of the wonderful fossils about 360 million years ago?
Okay, well, what we've got at Waterloo Farm, which is my principal site, is basically a fossil ecosystem, which was a sort of coastal lagoon.
Yeah.
And it's got a lot of material in it from terrestrial ecosystem, mainly plants, and also a lot of marine, more marginal marine things like fishes. And it's right up against the sort of ceiling of the End Devonian Extinction event. So it gives us a kind of picture of life immediately before the Devonian Extinction event, which is quite exciting, and includes most groups of vertebrates from the Devonian.
We know at the end of the Ordovician, a number of fishes went extinct, but we also see this wonderful radiation of fish in the Silurian and the Devonian, and now we have this incredible diversity at this time. Is that right?
Yes, you could say that during the Devonian, vertebrates reached their broadest diversity in the entire history of Earth. There were groups of vertebrates around in the Devonian that have been extinct ever since, and what we have now is a kind of subset of what was around in the Devonian.
Really? And what kind of fish were there?
Well, from Waterloo Farm we've got a lot of quite a huge. We've got about 20 kinds of fish. So the majority of specimens that we have are placoderms, and these were sort of armor-plated fishes. Their whole head and trunk was covered in a sort of armor plating, and there was a sort of ball and socket joint that allowed the trunk armor and the head armor to move. Which was important because jawed vertebrates need to be able to open and close their mouths. Also acanthodians, which we call spiny sharks. They were a bit like sharks, but they had a sort of bony spine on the leading edge of all fins other than the tail fin. And we also have sharks and a large range of lobe-finned fishes, including coelacanths and tristocopterids, which are ancestral to tetrapods, and ray-finned fishes as well, which are a really minor component of most Devonian ecosystems, including this one. But today they make up 80% of the fish that we have in the world.
Exactly. So at the end of the Devonian, we see the rise of these other fish that really become the dominant group. Is that correct?
Yeah. Well, this is the interesting thing. In the Devonian, most ecosystems are actually dominated by placoderms, these armor-plated fishes, and then large bony lobe-finned fishes were also very common.
Yeah.
And the most common kind of non-placoderm bony fishes in the Devonian were lobe-finned fishes. But of course nowadays there are only a few survivors, like modern coelacanths, lungfishes, and all of us tetrapods are in fact lobe-finned fishes as well.
Exactly, yes.
So what one had was at the end of the Devonian there was total extinction of all placoderms and the vast majority of spiny sharks. Some of them continued till the Permian and then died out then. And the most groups of lobe-finned fish also became extinct at the end of the Devonian. So that really left ray-finned fishes and tetrapods and just a few remnant groups of lobe-finned fishes.
So at your locality you have this diversity of high-latitude sharks. I mean, is there something special that you want to tell us about that locality?
Well, we've got very nice sharks. What we have at the locality, which is very special, is that we have soft tissue preservation.
Yes. So you have the outlines of the bodies of the sharks preserved?
Some of the very baby ones. I've got one about 2.8 centimeters long.
2.8 centimeters? Tiny?
Yeah,
wow.
that's a tiny little baby.
Yeah.
These sharks probably gave birth to live young.
Yes.
My current belief is they were actually coming into this estuary, this coastal estuary, to breed, as were the coelacanths.
Okay.
So they were breeding in the estuary. And then we have a lot of cartilage. Obviously cartilage normally breaks down.
Yeah.
It decays, but we've got skull, jaws, all sorts of shoulder girdle remains, which are all cartilaginous from these sharks. Which is really interesting because they're a really basal type of shark. So they're giving us some kind of idea about early conditions in sharks.
Goodness, wow.
And of course the soft tissue also means that we've got lamprey fossils, which are the oldest lamprey fossils in the world. Of course, lampreys are jawless fish.
Exactly.
In fact, they're the only jawless fish that survive until today. There's one from the Cretaceous, and then there's also a couple from the Carboniferous from North America. But the only Devonian one in the world is our one from South Africa,
which is called?
Priscomyzon guineensis, which is after Guinea, which is the traditional name for Grahamstown.
Okay, wonderful. But Rob, now we have this wonderful insight about what's happening in aquatic environments. But on land, do we have any clue about what's happening 360 million years ago?
Yes, well, this is what's really nice about this site as well, is that in addition to what was living in the estuary, we had a lot of particularly plant material coming in and falling into this estuary and being preserved in this anaerobic black mud, which preserves soft stuff. So we have a really good, which I'm still describing, a really good flora of plants, from really small kind of undergrowth plants through to Archaeopteris trees. And Archaeopteris trees are one of the earliest, they're actually the earliest widespread type of proper woody tree that you get in the world.
And how big are we talking? I mean, is it massive?
We're talking full-size trees. I mean, I've got a tree stump which is about this wide. So the interesting thing about Archaeopteris trees is that they were the first widespread trees that had progymnosperm type wood. And that meant that they could live away from water bodies.
And grow quite tall, I would think.
And grow tall, because they had to be able to pump the water from deep down right up to the crown.
Yes.
So I'm not sure exactly how tall they grew, but they got big. And that's really ties in very much with the End Devonian Extinction, because it's kind of almost the opposite of what's happening now with the greenhouse effect. The first forests spread all around the world, and in fact the Archaeopteris specimens we have from Waterloo Farm are the first record of high latitude Archaeopteris.
Is that so?
So that's given us the idea that Archaeopteris forests actually spread around the whole world by the end of the Devonian. And towards the end of the Devonian, one sees these climatic problems start developing, and that's partially because obviously forests are made out of carbon, and a lot of that carbon comes from the atmosphere in the form of CO2. So there was a massive drop in the CO2 level, and in addition the CO2 was also reduced because with the deeper weathering of these trees, humic acid, the breakdown of rocks brings about chemical reactions that also absorb CO2. And that brought about, or compounded by the fact that Gondwana was going over the South Pole at the time, and there was ice build-up on Gondwana, but that was compounded radically by this reduction of CO2. So one saw huge drops in global temperature, and you start seeing these little mini kind of cold snaps leading on towards a really cold phase. So the opposite of what's happening now, where people are digging up fossil plants and burning them and putting the CO2 into the atmosphere and things are getting hot, there they were getting cold. And it would undoubtedly also have had an effect on water pH and atmospheric gases, and that seems to have been how this one species actually triggered the second global extinction event.
So that's the end of the Devonian extinction.
Yeah, the End Devonian Extinction event was actually
triggered by Archaeopteris forests.
Yeah, they're probably compounding factors, but triggered by the spread of these big progymnosperm forests all around the world, and wiped out a very large percentage of life on Earth, including the vast majority of higher groups of vertebrates, which we've never...
So Rob, we know about this incredible diversity in the aquatic realm, and we know about the plant diversity, but what about the animals? I mean, do we have any inkling about what's going on in terms of animal diversity at this time?
Okay, well, we have inklings from around the world, and we also have local inklings from Waterloo Farm. We actually have described from there the earliest known terrestrial animal from Gondwana, which I named Gondwana Scorpia mzansiensis.
Scorpion.
It's a scorpion, a terrestrial type scorpion. And the very presence of that indicates that there would have been other invertebrates like millipedes and insects that would have been on land, because of course scorpions are predatory.
Exactly.
And this is interesting also because the creation of shady, cool environments on land by trees, and the inhabiting of the undergrowth of those forests by invertebrates are actually the prerequisites for what happened after the Devonian extinction event, which was the emergence of tetrapods onto land.
Exactly.
So in the late Devonian, we start seeing the first fossils of tetrapods. Those are four-legged creatures like us, but in the Devonian, they were sort of like giant salamanders that had a big tadpole-like tail.
Exactly.
And then after the extinction event, we see them on land. And somehow the sort of unfavourable conditions in the water maybe affected the move onto land.
Mm-hmm.
But
of course, and the land environments were now probably ideal for this radiation. It kind of sets the scene for the rise of the tetrapods.
that's correct, yeah. And of course, we're all descended. Every four-legged creature is descended from these sort of semi-aquatic tetrapods that we find in the late Devonian.
Wonderful. Thank you so much for coming, and thank you so much for talking to us. I think we've learned a lot from Rob, and it's been such a pleasure chatting to him about the diversity of life in the Devonian. Thank you.
Okay, thanks, Anusia.